Hi friends, this is Selvajang here. Welcome to my networking channel. Hope all are doing good and safe. And today let us discuss about OSPF packet type. So there are 5 different packets. First one is a hello packet. It is used for establishing the neighbor relationship with R2. DBD is nothing but a database description. So always R1 and R2 will share the topology database between both R1 and R2. So that will be sent in the form of database description packet. LSR is nothing but a link state request. Whenever R1 requests any update from R2, it will send a link state request to R2. And after receiving the request packet, R2 will send a update packet to R1. That is the LS update, link state update. So once the update received from R2, R1 will send a acknowledgement packet to R2. That we call it as an link state acknowledgement, right? So let us see the OSPF neighbor state. The first is a down state. That means it has not established any neighbor relationship with R2. So init is nothing but whenever the R1 send a hello packet, R2 will receive the hello packet. So after receiving the hello packet, it will add the packet to the neighbor. That means it will add the router ID information to its neighbor. So that we call it as a init state. So whenever the R1 receives a packet from R2, it will see its own router ID in the received neighbor packet. So that state we call it as a two-way state. That means R1 and R2 has established a bidirectional neighbor relationship with each other. That is a two-way state. Then it will the process of extort state. Extort is nothing but it will be selecting the master and the slave. So it will be selecting DR and the BDR. The DR is nothing but the router with the highest IP address, and the lowest IP address will be elected as a BDR. So this will be the DR and this will be the BDR. So that we called as a master slave relationship. So this is the process of selecting master slave relationship. It is a extort state. So once the master and the slave elected, it will started exchanging the DBD packets. Already told, right? That is a topology. What are the topology database information it carries, right? It will started sharing with R1. Then R1 will share the information with R2. So that is a state we call it as an exchange state. That is a process of exchanging the DBD packets, exchanging the topology information between the R1 and R2. Then loading state is nothing but whenever R1 and R2 request any information from each other, it will send a link state request, and that is the thing I told, link state request, then you'll receive the link state update. So that is a process of synchronization we call it as a loading state. And once both R1 and R2 has completely synchronized, then we call it as a full state. So these are the neighbor OSPF neighbor state, and these are the OSPF packet types I will discuss. So now let us go to the R1 and R2. Let us do a debugging session. So now let us go to R1 and let us quickly configure the routing protocol, router OSPF 100. So let us enable network 192.168.1.0.0.0.0.255 followed by area 0. And similar way, go to R2 and go to the configuration mode, router OSPF 100, and the network information is 192.168.1.0 followed by 0.0.0.255 followed by area 0, right? Both resides in the same area. So that is the thing I configure. So now let us check the neighbor relationship. Show IP OSPF neighbor. So still it is establishing the two-way state, right? So that means it is still, first it will be the down state, I already told, right? So it will be the down state, you need two-way, then it will go to extort state. So still it is taking, see, you are able to see, right? It will go to init, two-way, then it went to extort state. So extort it will be electing master and the slave relationship. After some time it will go to exchange state. Let us see that. Show IP OSPF neighbor. See, it is still in the two-way state. Yeah, see, now it has established a full neighbor relationship with R2. So these are the neighbor state what I told. So now what we can do, let us go and shut down the interface. Let us go to this interface and do a shut and no shut. So before that, let us enable the adjacency. How to enable is debug IP OSPF adjacency, and similar way I'm going to enable the adjacency to show how the neighbor relationship is established using these neighbor states, right? So let us enable the debug IP OSPF adjacencies. So now what we can do, let us do a shut and no shut. Interface fast Ethernet 0 by 0 shut and do a no shut. Yeah. So now we can do a no shut of the interface. See, now let us see what are things you are able to see. See, now we are able to see the packet, right? So now it will be the down state, then it init state, then it went to the two-way, right? Two-way communication. So then it will be electing the DR and the BDR relationship, right? So it is electing DR and the BDR. So first it is a down state, then it will send a hello packet, then it will establish a two-way neighbor relationship, that is a two-way state. Then it will be electing DR and the BDR. I already told DR is always the router with the highest physical interface or the loopback interface. Since I have not configured the loopback interface, it will always take the highest physical interface, that is 1.2. Then it selected BDR, that is 1.1. So once that is done, it will start at exchanging the databases, right? So that you can see here, it will selecting master and slave. Then it will start at exchanging the databases. So then after exchange, it will directly move from loading to full synchronized state. So this is how the topology works. This is how the neighbor relationship is established between the R1 and R2, right? So it has exchanged the databases after selecting the master and the slave relationship. What happened? It will move to the exchange state where it will be exchanging the databases. Then after that, it is, you are able to see, right? It is sending the link state request. This is the thing I told. This is a loading state, link state request. Then it will send a link state update from the neighboring router. Then it went to the synchronized mode. That means it is a process of loading stage. So process of loading is nothing but at that time only it will send the link state request and the link state update. So once it is completely synchronized, it will establish a full neighbor relationship. So let us see now. It has established a neighbor relationship. Show IP OSPF neighbor. So we're able to see the neighbor relation is selected. This means it has already established a full neighbor relationship. So DR is nothing but the neighboring router is a DR, right? So in this case, R2 is a DR because this is the highest IP address. So that is the reason you are seeing full DR. Similarly, go to R2 and check the neighbor. Show IP OSPF neighbor. So you will see full BDR. That means it is already established a full neighbor relationship. Synchronization is established, and this is elected as a neighboring router. 1.1 is elected as a BDR. So this is a DR and this is a BDR. So this is how the packet flow works, right? So now you understand the packet types and the neighbor state. I hope you understood. Thanks for watching. Please subscribe me for more videos. Thank you. Have a wonderful day.